Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue our numericals from the Chem and follower, and in this lecture we will cover the roller type follower, which is offset. Okay, so let's start this example. So you can see the given data here. Construct profile of cam suiting the following specification. Okay, the cam shaft, this is our first time the cam shaft related some data is there, which is 40 mm cam shaft diameter. Remember that in cam profile cam shaft diameter is doesn't related, because they always give, because drawing of the cam we need the least radius or base radius. This is the 40 mm given for the confusion of the student. To make the student confused between these two datas. Okay, remember that camshaft radius is not important for us. We are not using this data at any point. Okay, because we make the cam profile on least radius of cam. After that, roller diameter is a 25, so radius will be 12.5. Angle of lift is a 120 theta 1. Angle of fall or angle of return, remember that it is given here, angle of fall means return is 150. Lift of follower is a 40. Rise or stroke is given 40 mm. Number of poses are 2 equal interval. So the dual total remaining angle is divided into 2 equal parts, and consider will be theta 2 and theta 4. Okay, dual angles. During the lift there is a simple harmonic motion, and during the fall the motion is uniform acceleration. So remember that during rise simple harmonic motion, during return uniform acceleration. So after that you can check the speed of the camshaft is uniform. Line of stroke is offset with a 12.5 from the center of the cam. Okay, so you take all the data required from this given. Okay, so check this. Lift is a 40, 120, and how we will get here? Check this. How we will get these duals? Theta 2 and theta 4 is not given directly. They give the rise angle 120, return angle 150, and they say number of poses are 2 equal parts between the motions. So 120 plus 150, it is a 270, and remaining angle is a 90. So divided 90 by 2, so 45 theta 2 and theta 4 is a 45. Okay, you can check here, base radius is given here and roller radius. Check this, roller diameter is given in example, but roller diameter, and I am writing here RR, roller of radius, radius of roller, so it will be 12.5. Okay, let's start. So first of all we have to make the displacement diagram, which will be same as the last example. Remember that this total length will be 18 centimeter and height will be 14 centimeter, because it is given lift as a 40 centimeter. Okay, then you will divide this rise and return in 6 parts. Okay, this length, you know that this length will be 120 divided by 20, so it will be 6 centimeter here. And you can check this, there is a dual portion is given here. This is the dual portion here, and here the dual portion. Okay, so after that we are going to start the cam profile, and this is the lengthy, or I guess so in all the cam profiles, roller with offset is the lengthiest, or I can say a very confusing type, because there is a 3 circles are there. You know that in a knife edge only base circle is there. In roller with a radial means line of action pass through the center, there is a 2 circles, which you know that base circle and prime circle. And but in a roller with a offset there will be the 3 circles: offset circle, base circle and prime circle. Let's start. So first of all, make the base circle. Diameter is given here 25, so radius is given 25, so 50 mm diameter of base, and the roller radius is given, okay, 12.5, but I am not going to draw here. You can draw directly prime circle by adding these 2 values. Which value? Add these 2 value, 12 plus 25 plus 12.5. Okay, so it will be 37.5. Okay, and you can make the radius of 37.5 directly here, and you will get the prime. You will get the prime circle. Okay. So now I have made here prime circle by adding this 2 value 37.5, and now I am going to draw the offset circle 12.5 offset circle, okay, at a center. So this will be 12.5 radius, okay, radius of 12.5. So this is the 3 circles. First is a offset circle, base circle, and outer is a prime circle. Now same as in a knife edge offset. What you have done in a knife edge offset, first of all make the horizontal line, then vertical line, and whenever it intersect at a prime circle, this will be your point. Main first point means 0 point will be here, and we have to connect this point to the center, okay, like this, and it will be the reference line. Like in a knife edge, you have taken the all partition from this point, okay, so this is our reference line, and you can make the first circle here. Here you can make the first circle because we get the first point here, so you can draw the first circle at the center and connect this center at a cam center, and you will get the reference line, okay. And all partition we will make from this, like first angle is a 120 and then 45, so I am making this 120 here something, and then 45, and after that 150 is there, so 150. So I have make this 4 partition here. Check this, you can first 120, second 45, and third 150, and this remaining will be 45. So after that, you know that what we have to do, divide the rise and return in 6 parts. Rise and return, I have divided rise and this return in 6 parts, and then I have to make the tangent from these points, and which must contact with this offset circle, okay. So check this, like when you draw this tangent, this line, you don't know what will be the length of this tangent, so make sure they are in a larger length, so you can give this point A, B, C, D, E, F, G. So we will get these points, okay, here on this line, like B, C, D, E, F and G on this line, and then we are going to make the circle on every point, and then we will connect same as in ruler. Okay, so this will be your cam profile. So this is your cam profile. For the ruler offset, I will revise you again. First of all, we have to make here 3 circles. You can check this. 3 circles are there. First is a offset circle, second is a base circle, and last and outer circle is a prime circle. Okay. Then we have to make here horizontal line and vertical line. Whenever this line, vertical line, intersect the prime circle, this will be the point where you will make the first circle here. This will be the first circle here. Okay, and connect this circle to the center. Okay, you will connect this circle to the center here, and all the partition, like this is our first partition, second partition, and check this last partition. Theta 1, you can check this. Theta 1 is a 120, theta 2 is a 45, theta 3 is a 150 up to here, and remaining is a 45. So all partition will be with respect to this point. Remember that always connect this first roller to the center, and it will give you reference line, and with respect to that you will measure all angle from in a anti-clockwise direction. Okay, and after that you know that you will get these points here on a prime circle like this, 4, 5 and 6, same as in written 0, 1 dash, 2 dash up to 6 dash. Okay, and all points on a prime circle, remember that prime circle, and after that you will measure this distance here from 3 to D like this, and you will put center here and arc will be there, and you will get this D. Same as for to E, this distance, take from distance here 4 to E, take this distance measured or using compass, 4 to E, same as 5 to F, 5 to F. So that's how you will get the all these points E, F, and make circle at every point here, and draw the profile which is smoothly touch every circle in a profile. Okay, that's it. Thank you.